Welcome to the Cognito Pod. You know, we all use these digital assistants all the time, right? Like Alexa and Google Assistant.
Yeah, yeah.
And it seems so instantaneous, right? I
Oh,
mean,
yeah.
I ask a question or tell it to do something and it just does it.
Right.
But there's a whole bunch of stuff going on behind the scenes.
Yeah.
So today we're going to kind of take a deep dive into how these virtual assistants actually work from the moment you say the wake word to the response. You know, you'll have a better idea of how complex these systems really are.
Absolutely.
So let's get started. The journey begins, really, when you say the wake word right, whether it's Hey Alexa or Okay Google.
Right.
And the device is always listening in a low-power state, just waiting for you to say that phrase.
Exactly.
And once it detects that wake word, it kicks into gear and starts processing your command.
That's right.
So it's like it's waiting for that specific sound, right?
Mm-hmm.
Like a trigger, and it's all happening right there on my device.
Yeah. So wake word detection is handled by a tiny neural network right on the device. It's always analyzing the sounds around it, comparing them to the stored model of the wake word. And this local processing is what makes it so fast. The system reacts almost instantly. And it also helps protect your privacy because the audio doesn't leave your device until it hears the wake word.
So it's private and super fast.
Exactly.
But I'm guessing it's not always perfect, right? Sometimes it might accidentally wake up, or it might not hear me when I say the wake word.
Yeah, that's the challenge, the speed versus accuracy trade-off. You know, a really sensitive model might pick up false positives, like if it hears something that sounds like the wake word but isn't.
Oh, right, like a TV.
Exactly. And on the other hand, if it's not sensitive enough, it might miss the real wake word. So product managers are constantly trying to find that sweet spot between the two.
I see. So you don't want to waken up all the time, but you also don't want to have to shout at it.
Exactly.
And I imagine privacy plays a role here too, right?
Yeah, it does. Processing locally on the device is great for privacy. But on-device resources are limited compared to the cloud, so sometimes there's a trade-off between privacy and performance.
So it's always about finding that balance.
Right.
But there must have been some like breakthroughs in this area, right? I mean, it seems like it's gotten a lot better over the years.
Oh, definitely. For example, Alexa saw a 25% improvement in wake word accuracy by using a hybrid neural network model on the device, and Google Assistant reduced false positives by 30% by using federated learning.
Federated learning. What's that?
It's a way for the model to learn from data on lots of different devices without actually collecting the raw data. So it improves privacy and still makes the model smarter.
So everyone's helping to train the model without even knowing it.
That's a good way to put it.
Okay, so let's say the device has heard the wake word. Now what happens?
Okay, so once the wake word is detected, your voice recording, the actual request gets sent to the cloud for more processing. And the next step is automatic speech recognition, or ASR. That's where your speech is converted into text.
So it's like writing down what I'm saying, but in real time.
Yeah, basically.
And how does that work?
ASR uses really complex, deep learning models that are trained to recognize patterns in speech. They break down your words into individual sounds and then statistically predict the most likely words based on all the data they've been trained on.
Wow, it sounds complicated.
It is. And speed is super important here, too. Google Assistant aims for a response time of under 200 milliseconds.
100 milliseconds, that's like snapping your fingers.
It is. And that means the ASR has to work super fast.
I can see why that would be a challenge.
Exactly. And then you have the issue of noise. The system needs to be able to understand you even if there's background noise.
Oh, right, like if I'm in a crowded room or something.
Right. So Google Assistant, for example, has been trained on over 50 billion audio samples with all sorts of different noise conditions.
50 billion, that's a huge amount of data.
It is. And Amazon also improved their speech-to-text speed by about 15% by switching to a different kind of model called a transformer.
So they're constantly improving these models.
Absolutely.
Okay, so now we've got the audio turned into text.
Yeah.
What happens to that text?
That's where natural language understanding, or NLU, comes in. It takes the transcribed text, like, what's the weather today, and figures out what you actually mean.
So it's not just words on a screen. It actually understands the meaning behind them.
Right. It has to identify the intent, which in this case is to get the weather, and then extract relevant information like the location and time.
So it's kind of like translating my question into something the computer can work with.
Yeah, you could say that.
So how does it actually do that?
NLU systems use really powerful language models like GPT or BERT. These models have been trained on massive amounts of text and code, so they're able to understand the nuances of human language, like grammar, meaning, and context.
That's amazing.
And they often use information from your previous interactions to understand your current request better.
Oh, like if I asked about the weather in San Francisco yesterday, it might assume I'm still interested in San Francisco today.
Exactly. That's how context comes into play.
And I've noticed that these assistants are getting better at remembering things from previous conversations.
Yeah, they're adding features that can store information from past interactions, which makes the conversation more natural. Alexa's memory feature, for example, saw an 18% increase in customer retention because it allowed for more natural follow-up questions.
So remembering things actually makes people use the assistant more.
It seems so. And that leads to another important trade-off, context awareness versus privacy.
Right, because remembering things means storing data.
Exactly. And companies have to be careful about how they manage that data. Google Assistant, for instance, only keeps session data for about 30 seconds to help with context, and users have control over their privacy settings.
So they're trying to find a balance between providing a good experience and respecting privacy.
Right.
And what about those times when you ask multiple questions in a row? Like, what's the weather like? And what about tomorrow?
That's called multi-turn conversation, and it's another challenge for NLU systems. They need to keep track of the entire conversation and understand how each question relates to the previous ones.
So it's not just about understanding individual sentences, it's about understanding the whole conversation.
Exactly. And Google Assistant actually improved their accuracy in these kinds of conversations by 20% by using a new architecture that's better at handling sequences of information.
So it can actually follow along with the conversation.
Mm-hmm.
Okay, so now the assistant understands what I'm asking. How does it actually come up with a response?
That's the response generation stage. First, it has to find the relevant information, like in our weather example, it needs to access the latest weather data. Then it has to put that information into a natural-sounding response. And finally, it uses text-to-speech, or TTS, to convert that response into audio.
So it's a whole process just to answer a simple question.
It is.
And are there any trade-offs in this stage?
Yeah. One of the big ones is accuracy versus personality.
What do you mean?
Well, should the response be perfectly accurate, even if it sounds a bit robotic? Or should it be more casual and engaging, even if that means there's a slight chance of a small error?
I guess it depends on what you're asking about.
Right. But Alexa's team found that a more informal tone actually increased user engagement by 12%.
So people prefer a more friendly assistant.
It seems that way. And then there's the tone and style of the TTS voice itself. Google has been working on making their TTS sound more natural, like adding in the little variations in pitch and rhythm that we use in normal speech.
Yeah, I've noticed that it doesn't sound so robotic anymore.
Right. And Alexa found that adding a little pause before a joke actually made people laugh more.
So those little details really matter.
They do.
Okay, so I've got my weather report.
Mm-hmm.
What happens next? Does the assistant just forget about me?
Not exactly. That's where feedback and learning come in. The system records our interaction and any feedback you might give, and it uses that information to improve all the models we talked about, from wake word detection to response generation.
So it's constantly learning and getting better.
That's the idea.
And this is where personalization comes back into play, right? Because the more it learns about me, the better it can tailor its responses.
Exactly. And that can lead to a much better user experience. For example, Alexa's personalized news briefings increased user retention by 30%. But of course, there's the privacy issue again. Companies have to be very careful about how they use and store personal data.
Right, so it's a balance between personalization and privacy.
Mm-hmm.
And there's also the question of whether the system should focus on individual users or just general trends.
That's right. Individual analysis can be more powerful for personalization, but it also raises more privacy concerns.
So it's a complex issue.
It is. And all of this is happening on a massive scale. Google Assistant improved its accuracy by 18% just by analyzing incomplete queries and filtering them out.
So even mistakes can help the system learn.
That's right.
Okay, so we've covered the whole process from wake word to response.
That's true.
But this is all built on a lot of complex technology, right?
Yeah.
What are some of the key engineering challenges involved in creating these systems?
Yeah, so beyond the product level trade-offs, there are some really important technical considerations. For example, there's latency versus accuracy.
What does that mean?
Basically, it means that making the system respond faster might mean sacrificing some accuracy.
Oh, right, because if you want a fast response, you might have to use a simpler model.
Exactly. And Google Assistant aims to respond in under 200 milliseconds, which is incredibly fast. So they have to be really smart about how they optimize their models.
And they've done some pretty impressive things, right? Like using on-device models for common queries.
Yeah, that reduced latency by more than 20% for those queries. And Amazon also uses a hybrid model that handles some requests locally, which sped things up by 30%.
So there are different ways to achieve that balance between speed and accuracy.
Right. And the key metrics here are keeping latency below 200 milliseconds and response accuracy above 95%.
So it's a constant balancing act.
It is.
And what about the complexity of the models themselves? Does that play a role?
Definitely. That leads to the model complexity versus compute cost trade-off.
So bigger, more complex models are more powerful, but they also require more computing power.
Right. And that means higher costs and more energy consumption.
So it's a trade-off between performance and efficiency.
Exactly. Google, for example, implemented the BERT model, which is a very large and powerful language model. But to do that, they had to invest heavily in their TPU infrastructure,
TPU.
tensor processing units. They're specialized hardware designed for machine learning.
So they had to build special hardware just to run this model.
Yeah. And Amazon's switch to transformer models also led to increased memory requirements.
So even though they were more efficient in some ways, they also required more resources.
Right. So engineers are always trying to find ways to make these models faster and more efficient without sacrificing accuracy.
I see. And what about all the different languages these assistants support? That must add another layer of complexity.
Absolutely. That's the multilingual support versus model size trade-off. Supporting more languages usually means bigger models and more training data.
So the trade-off between language coverage and performance.
Right. And there are different approaches. Google, for example, developed a universal multilingual model that supports over 30 languages.
Wow, that's impressive.
It is, but it also increased their compute load by about 40%. And Amazon moved to a single multilingual model for European languages, which made things more efficient, but also resulted in a larger model.
So there's no easy solution.
Right. The goal is to support as many languages as possible while keeping the model size manageable.
And then there's personalization, which we talked about earlier. But that also presents some engineering challenges.
And definitely, that's the personalization versus privacy trade-off from an engineering perspective.
So it's not just about respecting user privacy. It's also about designing systems that can actually handle personalization.
Right. And it's not just about storing data, it's about processing it efficiently and making sure users have control over their information. Google Assistant, for example, uses opt-in personalization for features like routines. So users have to explicitly choose to share their data.
And Amazon gives users the option to opt out of custom voice profiles.
Exactly. So engineers are constantly working on ways to make personalization work without compromising privacy.
It sounds like a tricky balancing act.
It is. And finally, there's the issue of scalability.
Right, because these systems have to handle millions of users.
Hundreds of millions, actually. And that brings us to the scalability versus consistency trade-off.
What does that mean?
It means that as the system grows, it has to be able to handle more and more users without slowing down or becoming unstable.
So it's not just about building a system that works, it's about building a system that can handle huge amounts of traffic.
Exactly. Amazon, for example, had to move to a multi-region architecture to handle the massive growth of Alexa. And Google uses edge computing, which means processing some requests closer to the user to reduce latency.
So there are a lot of challenges involved in scaling these systems.
Definitely. And engineers are constantly working on new ways to make them faster, more reliable, and more efficient.
It's really amazing how much thought and effort goes into building these systems.
It is.
And it's all for a service that most people use for free.
Right. So how do these companies actually make money from these virtual assistants?
That's a great question. Because you're right, they are free to use.
They are. But there are a lot of ways these companies generate revenue indirectly.
Let's start with e-commerce. I know I've definitely bought things using my smart speaker.
Right, e-commerce and transaction fees are a big part of it. By enabling voice shopping, these assistants drive sales, and the platforms can either take a cut of those sales or just benefit from the increased volume.
So it's like having a personal shopper right there in your living room.
Kind of. And Amazon is a good example. They make it super easy to reorder products you've bought before, and their recommendations often favor Amazon products, which helps boost their sales even more.
It's pretty smart.
It is. And in 2022, Alexa was estimated to have generated about $2 billion in sales for Amazon.
Wow, $2 billion.
Yeah.
That's a lot of toothpaste and paper towel.
It is. And Google also partners with retailers like Walmart and Target, and they get a fee or a percentage of sales for voice purchases made through Assistant.
So everyone's getting a piece of the pie.
Right. And the convenience of voice shopping is a big draw for users, so it's a win-win for everyone.
Except maybe my wallet.
Maybe. But what about advertising? Have you ever heard ads on your smart speaker? Advertising and sponsored search results are still a big revenue stream.
How does that work?
Well, when you ask for product recommendations or local services, the assistant might prioritize sponsored listings.
So it's like the top result in a search engine, but for voice.
Exactly. And Amazon has been known to promote sponsored products in their responses. And Google makes a lot of money from advertising. Their main revenue source is actually search advertising, which brought in over $280 billion in 2023.
That's an incredible amount of money.
It is. And they're using that same approach with Google Assistant. So if you ask for a plumber, for example, you might get recommendations for businesses that are paying for Google's local services ads.
So it's all about leveraging that user intent.
Right. And even Apple Siri, which doesn't serve ads, directly contributes to Google's ad revenue through their search engine deal.
I didn't know that.
Yeah, Apple reportedly makes over $15 billion a year from that deal.
So even though Siri isn't directly involved in advertising, they're still benefiting from it.
Exactly. And voice search is becoming more and more popular. So the potential for advertising revenue is only going to grow.
That makes sense.
Yeah.
What about all those third-party skills and actions? Do the platform owners make money from those?
Yeah, the partner ecosystem and skill or action revenue is another important piece of the puzzle. Amazon and Google encourage developers to build new functionality for their assistants, and they often take a cut of any revenue generated by those developers.
So it's like an app store, but for voice.
Exactly. For example, Amazon takes a 30% cut from in-skill purchases in Alexa skills. So if you buy a premium feature in a game or subscribe to a service through Alexa, Amazon gets a share.
And Google does something similar with their actions.
Right. They allow developers to monetize their actions through subscriptions, premium content, and other methods.
So it's a way to expand the capabilities of the assistant while also generating revenue.
Mm-hmm. And it encourages developers to build more and better skills, which benefits users in the end.
It's all very interconnected.
Yeah.
It's like once you choose an assistant, you're kind of locked into their ecosystem.
That's true, and that's no accident. Product and platform lock-in is another deliberate strategy for revenue generation. By tightly integrating their assistants with their other products and services, these companies encourage you to stay within their ecosystem.
I see. So if I use Alexa, I'm more likely to use Amazon Prime Video and Amazon Music.
Exactly. And if you use Google Assistant, you're more likely to use YouTube Premium and other Google services. And Apple Siri is tightly integrated with Apple Music and other Apple services.
So it's all about creating a seamless experience that keeps users engaged.
Right. And that leads to higher customer lifetime value and more revenue for the companies.
Okay, so we've talked about e-commerce, advertising, third-party skills, and platform lock-in. What about all the data these assistants collect? Is that a source of revenue?
Data monetization is a huge factor, although it's often indirect. These assistants gather a massive amount of data about user behavior preferences and usage patterns.
And they can use that data to improve their products and services, right?
Exactly. But they can also use it for advertising. For example, Google can use data from Assistant to target ads on YouTube more effectively.
So the more they know about me, the better they can target ads to my interests.
Right. And Amazon uses data from Alexa to improve product recommendations and make their supply chain more efficient.
So they're using data to improve every aspect of their business.
Exactly. And even Apple, which is known for its strong privacy stance, uses anonymized Siri data to refine content recommendations in Apple News.
So even with strict privacy controls, data is still incredibly valuable.
It is, and it's only going to become more so as these assistants become even more integrated into our lives.
Okay, last question. Are there any direct ways these companies make money from these assistants, like subscriptions or premium features?
Yes, we are starting to see more direct monetization models emerge. For example, Amazon offers Alexa Emergency Assist for a monthly or annual fee. It provides advanced safety features like fall detection and emergency calling.
So it's like a premium service on top of the basic assistant.
Right. And Google has YouTube Premium, which integrates seamlessly with Google Assistant for ad-free content and background playback. And Apple, of course, has Apple Music, which is deeply integrated with Siri for voice control.
So there are definitely ways for these companies to generate direct revenue from these assistants.
And I think we'll see more of that in the future as these platforms mature.
So what does the future hold for these virtual assistants? I mean, it seems like they're already everywhere.
They are. The adoption rates are pretty amazing. As of May 2023, there were over 500 million Alexa-enabled devices out there. And Google Assistant was integrated into over 1 billion devices globally.
1 billion. It's hard to even imagine.
It is. And all the major players are investing heavily in new AI capabilities.
So what can we expect to see from Amazon and Google?
Well, Amazon is planning to launch Alexa Plus in 2025.
Alexa Plus.
It's an AI-enhanced version of Alexa with more advanced conversational abilities, better music integration, and enhanced smart home control.
So it's like Alexa on steroids.
You could say that. It'll be a premium service costing $19.99 a month, but it'll be included for Amazon Prime members.
So they're trying to attract more Prime subscribers.
Exactly. And they're also partnering with Anthropic, which is an AI company, to give Alexa Plus even more capabilities, like image analysis, advanced smart home automation, and more complex purchase options.
So it's going to be a lot more powerful than the current Alexa.
Definitely. And Google is transitioning their assistant to a new AI platform called Gemini. And users are already seeing some upgrades to Gemini, and the classic Google Assistant will actually become unavailable on most mobile devices later this year, except for older Android versions with limited RAM.
So they're really pushing this new platform.
They are. And they're also planning to bring Gemini-powered experiences to their home devices.
So it's going to be interesting to see how this all plays out.
Absolutely.
What about Apple? Seems like they've been a bit quiet on the AI front lately.
Yeah, there have been reports that Apple has faced some delays with their new generative AI features for Siri.
So why is Apple behind?
It seems like they've had some internal conflicts about priorities and also some quality issues with the new features.
So they're being more cautious.
It seems so. And the latest rumors suggest that these new AI features won't be released until iOS 19, which could put them at a disadvantage compared to Amazon and Google, who are moving much faster.
So it's a race to the top.
It really is. And these delays could hurt Apple in the long run.
It's incredible to think about how far these virtual assistants have come in just a few years.
Yeah, and we're just scratching the surface of what's possible. With all the advancements in AI, these assistants are going to become even more powerful and integrated into our lives.
I'm excited to see what the future holds.
Me too. It's a really exciting time to be following this technology.
Well, I think we've covered a lot of ground today. Hopefully our listeners have a better understanding of the complexities behind these seemingly simple interactions.
Yeah, it's a fascinating journey from wake word to response.
And it involves a lot of cutting-edge technology, strategic decisions, and business considerations.
It really does.
So the next time you ask Alexa or Google Assistant a question, remember all the work that went into making that interaction possible? It's a testament to human ingenuity and the power of AI.
Absolutely.
Thanks for listening to the Cognitopod.